In this video, we're going to look at finding the nth term of a linear sequence. A linear sequence is often called an arithmetic sequence, and we either have the numbers going up by a fixed amount or going down by a fixed amount. So an example of a linear sequence could be 2, 5, 8, 11, then we'd have 14, ... and so on and so forth. We can see now that it's increasing by 3 each time. So this is going to be adding 3. So we're just adding 3 each time. If we had, for example, now 5 and then we had now 1, we had -3, we had -7 and -11. This is going to be arithmetic as we're going down by 4, we're going down by 4, down by 4 and down by 4. Examples of sequences that are not, if we have, for example, 1, 4, and then we have 9, we have 16, 25 and so on and so forth. This isn't increasing by a fixed amount. These are the square numbers. So we could say that this one is linear, this one is linear or arithmetic, and this is not linear. Just make sure that you do check all of the numbers. So for example, if we had one that was 3, then we had 6, we had 9, we had 12 and 16, we can look and it's going up by 3 until this point where it's going up by 4. So that is not linear, it's not arithmetic. We're going to look at generating terms of a sequence and then go on to look at the arithmetic sequence, both in terms of just numbers and functional questions. So we're asked to find the first 5 terms in the sequence. So in the first one we have 2n plus 1. One way that you might want to do this is to put it in a table. You certainly don't have to, but it might help you out. It'll certainly help us out with later examples if we're not confident. So what we're going to have then is 2n plus 1. So these are going to be my values then, and this now is going to give me the term in the sequence. So if we think when n is equal to 1, we're going to do 2 lots of 1, which is 2, plus 1, which gives me 3. When n is equal to 2, we're going to have 2 lots of 2 plus 1, which is going to give me 5. If I take n to be 3, 2 lots of 3 is going to be 6, plus the 1, that's going to give me 7. If I take now 4, 2 lots of 4 plus 1 is going to give me 9. And then finally, when n is 5, 2 lots of 5, and then we're going to plus 1, it gives me 11. We can see now that this is increasing by 2 each time. That is the number now in front of the n. It's positive 2, so it's going to increase each time. Okay, let's look at the next one. We have 5n minus 3. What you could do is simply write when n is equal to 1, we would have on here 5n minus 3 is going to give us a total of 2. So we can just simply write 2. If you want to write the term is 2, when n is going to be equal to 2, we're going to have 5 lots of 2, which is going to give me 10, minus the 3, which is going to give me 7. If n is going to be equal to 3, 5 lots of 3 is 15, minus the 3, that's going to give me now 12. We can see that this one is going up by 5 each time. I prefer to put it in a table, but I understand that some people might think it's a little taxing. This one is interesting. These two have been going up each time, and the reason they're going up is because we have a positive number in front of n. This one has a negative number. This sequence could be written as 7 minus 3n. It's exactly the same as now negative 3n plus 7. What we're going to do is just go ahead and draw up the table and put in the values. So I'm going to have n, and then I'm going to have, and I could have carried on for 2 more with that. Hopefully you see where we go. So n and then t. So we'll take 1, 2, 3, 4 and 5. We'll generate the first 5 terms. So if I do negative 3 lots of 1, that's going to give me now negative 3, plus 7 is going to give me 4. Alternatively, you could say that this is 7 minus 3 lots of 1, which is going to give us 4. If we look at this one, negative 3 times by 2 is negative 6, plus the 7 is going to give me 1. If we look at this stage, I could keep generating the terms, or we could just say, well, it's actually going down by 3 each time. So if I think on the next one, this is going to be negative 2, and we would know that anyway, because if I did negative 3 times by 3, that's negative 9, plus the 7 is 2. It's going to go down by 3 each time, so this is going to be -5, and then we'd have -8. So you can, of course, calculate them. So what we're going to do now is look at working the other way. So let's say we were given these terms. So we've got 3, we've got 5, we've got 7, we've got 9, and we've got 11. We might be asked to find the nth term of this sequence. A common error is students write it's n plus 2. N plus 2 is not the sequence. It is increasing by 2 each time, but it's not n plus 2. So for example, if we looked and we said that it was n plus 2, then what we would have now is the following. This would be n, so n, and we'd have t. We'd have 1, 2, 3, 4, and 5. Well, when n is 1, yes, we do get the 3. But when n is 2, 2 plus 2 is going to give me 4. When n is on here, 3 plus 2 is going to give me 5. We can see that this is not the case, as this is only going up by 1 each time. So what we need to do is find the nth term. That's what we're going to look at doing on the next few questions. We're asked to find the arithmetic nth term formula for the following sets of numbers if one exists. So let's look at this one. This one is going up. Firstly, it goes up by 4, then it goes up by 3, then it goes up by 3, then it goes up by 3. This is not arithmetic. It's not increasing or decreasing by the same amount. We do need to check. If we said now, for example, this one was going to be 4, 7, 10, 13 and 16, it would be. So let's go ahead and change that over, and we'll write that this is going, we'll make it arithmetic. We'll have 4, 7, 10, 13 and 16. We can see that this is increasing by a fixed amount each time. It's going up by 3. What I'm going to do is set up a table. This certainly isn't mandatory, but it might help you out. What we're going to have is n, and we're going to have now the term in the sequence. So this is the number, and this is the term. We'll have 1, 2, 3, 4, and 5. And we have the terms 4, 7, 10, 13, and 16. I say to myself now that it's going up by 3 each time. So all I'm doing now is going up by 3 each time. Therefore, what we can write is that the first part of this is going to be 3n. We saw now that in the last part, if it was going up by 2, we'd have 2n. So when n is equal to 1, so I know I'm starting off with this, when n is equal to 1, 3 lots of 1 is going to give me 3. I say to myself, what do I need to add or subtract to get from 3 to 4? The answer is just plus 1. I just need to add 1 on. So this is the nth term for that linear sequence. So if we look what I've just done, I found that it goes up by 3 each time. So I start with 3n. I then let n be equal to 1. 3 times by 1 is 3, but I need to make it to 4, so I add 1 on. Does that work for the second one? Well, 3 times by 2 is going to give me 6, plus 1 is 7. 3 times by 3 plus 1 is 10. 3 times by 4 is 12, plus 1 is 13, and we can see that it works. So this wasn't n plus 3, it was 3n plus 1. Okay, let's look at the next one. So this one right here, 5, so it's going up by 2, by 2, by 2, and then by 3. This is not arithmetic. So let's go ahead and make it arithmetic or linear. Linear just means it's going up by a fixed amount, or we could draw it in a straight line. And we'll make this one 5, 7, 9, 11, and we will make it 13. We can see that it's now increasing by 2 each time. So if I go ahead and put this in a table, after a while you might not need to do a table because it should or could be fairly obvious. So if we look now, we're going to have n and we're going to have t. We're going to have 1, 2, 3, 4, and 5. We've got 5, we've got 7, we have 9, we have 11, and we have 13. It's going up by a fixed amount each time, and that is plus 2. So we start with positive 2n. That is the first part. So when n is equal to 1, 2 lots of 1 is going to give me 2. What do I need to get to 5? The answer is I need to add 3. So my sequence is 2n plus 3. Does it work for this one? Well, 2 times by 2 is 4, plus 3 is 7. Does it work for this one? 2 times 3, that's 6, plus 3 is 9. So we can say now this is the nth term formula for the sequence. Okay, let's look at the next one. 11, 7, 3, and then we've got negative 1, negative 5. This is arithmetic, and it is decreasing by 4 each time. So if we just look at that, that one's not going to be much good. Let's put on this one. Let's go ahead and put this one on. So this time we're going to have a negative value in front of the n as it's decreasing. So let's go ahead and we can put in n and we can put in t. We have 1, 2, 3, 4 and 5. I'm going to have 11, I'm going to have 7, I'm going to have 3, I'm going to have negative 1 and negative 5. So it's going down by 4 each time. So negative 4, negative 4. So we can say this is going to now be negative 4n. That's what I start with. So when n is going to be equal to 1, what we'll have is minus, or if you like, negative 4 times by positive 1, which is negative 4. What have I got to do to get now from negative 4 to 11? The answer is I need to add 15. So this now is minus 4n plus 15, or we could say 15 minus 4n. So does that work now for each of these? Well, let's look at it this way around. 15 minus 4 lots of 2 is 15 minus 8, which is 7. 15 minus 4 lots of 3, which is 12, gives us 3. 15 minus 4 lots of 4, which is 16, gives us negative 1. We can see that it works. So this is the nth term. We can write now that negative 4n plus 15, or 15 minus 4n. Okay, let's look at this one. This one is increasing by 1/2, 1/2, 1/2 and 1/2. So that is linear. It's jumping up by a half each time. This one is slightly different, and we'll see now exactly why. Let's put this on. So what we've got then is n. This is the number. We have 1, 2, 3, 4 and 5. The term in the sequence, we've got now 0.5 or 1/2. We've got 1, we've got 1.5, we've got 2 and we've got 2.5. It is increasing now by half each time. So what we're going to have is the following. We're going to have 0.5, or if you like, 1/2 n. If I think about this now, when n is equal to 1, so if we just have n is equal to 1, I'm taking this first one. We're going to have 1/2 of 1, which is going to give me 1/2, or if you like, 0.5. Therefore, we don't need to add or subtract anything to it. So it's simply now 1/2 n. Because we've got nothing to jump up to, I'm already at the 0.5. We don't need to add any value or constant, if you like, to that. If we look, does it work for this one? Well, half of 2 is 1. Half of 3 is 1.5. Half of 4 is 2. Half of 5 is 2.5. So we found now the nth term. In part E, we're asked to find the 100th term in each sequence. So if we just write out the sequences, our first one just here, and we'll just jot this down, the first one was 3n plus 1. Once we've changed it, it was 3n plus 1. The second one was 2n plus 3. The third one we had now negative 4n plus 15, so negative 4n plus 15, or if you like, you could say 15 minus 4n. And then finally, we just had 1/2 n, or if you like, 0.5n. So we now want to find the 100th term. All this is telling me now is to let n be equal to 100. So all I'm going to do is take this and substitute it in each time. So 3 times by 100 is 300, plus the 1, we can say now that this would be 301. When n in this one is 100, 200 plus 3, 203. In this one, minus now 4 lots of 100, that's going to give us negative 400, plus a 15, we're going to have negative 385. That one, remember, is going down. When n is 100, half of 100 is 50. So this gives us now the 100th term in each sequence. If we wanted the 34th term, all we would do at this stage is simply sub in that n was equal to 34. So just subbing in to each of these. Okay, let's move on and look at something different. We're asked to find the formula which describes each sequence below. So if we look at this one, is it going up by a fixed amount? 5, 5, 5 and 5. If you wanted, you could put it in a table, but we could simply write now that this will start with 5n. So this is going to be the first term in the sequence. 5 times by 1 is 5. What do I need to do to get to 4? The answer is minus 1. So I'm going to subtract 1 to give me 5n minus 1. Does it work for this one? Well, this is 2. 5 times by 2 is 10 minus 1. If we now look at part B, this is going up by 3 each time. So we know it will start 3n. Remember, this is going to be 1. 3 times by 1 is 3. I need to add 8 to get to 11. That will give me 3n plus 8. Does that work? Well, if this is 2, 3 times by 2 is 6, plus 8 is 14. 3 times by 3 is 9, plus 8 is 17. So yes, it does work. If we look at the next one, that's going up by 6, 6, 6 and 6. So we can say positive 6n. If this was 1, 6 times by 1 is 6. What do I need to do now to get to this negative 2? The answer is I need to now subtract 8. So I'm going to have 6 and then we're going to subtract 8. So let's check that works. Remember, this one is going to be the second one. So that's 1, that's 2, that's 3. Is 6 times by 2? Well, that's 12. Minus 8, yes, that's 4. 6 times by 3 is 18. Minus 8 is 10. If you're still using a table, that's perfectly fine. And I suggest that you do it if you're asked to show working. So if the question gives you marks. So let's look at that one. This is going down by 2 each time. So 2, 2, 2. So we're going to start now with negative 2n. So if I think about this, this is 1. Negative 2 times by 1 is going to give me now negative 2. So I'm going to have to add back on 102 to get there. So plus 102, or you could say that this is 102 minus 2n. Either way round, that will give us a value. So I've taken this to be 1, and we've gone from there. So hopefully you can see from here, I mean, this one is going up by 1/2 each time. This one is going down by, on there, 7 each time, and so on and so forth. I think what we'll do now is look at some questions now that try and, well, push us towards finding certain terms. Okay, is the number 57 in each of the following sequence? If so, which term is it? So if we look at this now, we've got 2n plus 1. So when n was equal to 1, we'd have 2 times by 1 plus 1, which would give us 3. We would have now, when n is 2, we'd have 5, we'd have 7, we would have now 9, and we would have so on and so forth. Of course, we could keep going up to see if 57 was in there. Alternatively, all we need to say is now that if it is in there, 2n plus 1 will be equal to 57. Solving this equation for n, subtracting 1 from both sides, 2n is going to be equal to 56. Dividing both sides now by 2, n would be 28. Yes, it will be in there because this is a whole number. If this comes up not to be a whole number, it won't be in there. So we can say that it is in there and it's the 28th term. So for example, if my answer now was 26.5, then it's not in there. If it was 29.2, it's not in there. So let's look at this one. If now 57 is in there, the equation 5n minus 3 equals 57 will give us now an integer or whole number value for n. So adding 3, 5n is equal to 60. Dividing both sides by 5, n is equal to 12. So that's a whole number. Yes, it's in there, and it's going to give us the 12th term. Students often say, I'll just count up. If that's the case, let's make this 5,317. Ideally, we look to solve an equation. So if we go for the next one now, we've got negative 3n plus 7 is going to be equal to 57. So if we look at this one, I'm going to now subtract 7 from both sides. So negative 3n is going to be equal to 50. Dividing both sides now by the negative 3, we can clearly see now that n can't be a negative number, and 50 divided by 3 certainly doesn't give us an integer. So we can clearly see that this is not going to be in there. We can see that for two different reasons, but hopefully that makes sense. So if we're asked to find whether a number is in the sequence, we simply set up a little equation. If it gives us a whole positive number now, yes it is, and then we can say which term it is. If it gives you a whole negative number, it can't be in there because n must be greater than 0. Okay, let's move on. Sheep enclosures are built using fences and posts. The enclosures are always built in a row. So we've got enclosure 1, 2 and 3. We've got the post and the fence. In part A it says sketch 1, 4 enclosures in a row and 2, 5 enclosures in a row. So all we're going to be doing is adding 1 on. We can see now that it's just a case of that. So what I'm going to do, I'm just going to put these on here. In fact, we'll just draw them to the side. No, I'll hand sketch them on because I don't think this is going to look brilliant anyway around. So what we're going to have then, if I do the next one, we're going to have that, we're going to come down, and then we're going to have that. So that's what it's going to look like. Remember, this is just a sketch. So that would be now the 4 enclosures in a row. And of course, if we wanted to do another one, we would simply go down like so. You wouldn't do this on the exam paper. It's just I'm thinking about the space here and the time, but we would draw them to the side. So if we look at this, we're asked to copy and complete the table below. So the number of enclosures and the number of posts. So on the first enclosure, we can see there are 6 posts. So 1, 2, 3, 4, 5, 6, or the other way around if you want to go clockwise. Each time we're adding now one of these enclosures, we can see that we're gaining 3 new posts. And that is clear by this value going up by the fixed amount of 3. So we can say 15, we can say 18, 21, 24 and 27. So it's just going up by that fixed amount each time. So if we look for each of these now, we could say that there were going to be on here 2 on each jump up. We're going to have 3 new posts and we're going to have 4 new fences. 1, 2, 3, 4. Okay, so we've done that. We're asked to work out the number of posts needed for 20 enclosures in a row. We could just go ahead and start adding multiples of 3 at this stage. And we could think about needing another 12 enclosures. Now if it's going up by 3 each time, we can multiply 12 by 3 and add it on. I think answering the next part of the question is a better way round to do it. So for example, if I wanted to know how many posts were needed for 63 enclosures, I wouldn't want to try and do the maths that way. So in part D, we're asked to write down an expression to find the number of posts needed for n enclosures in a row. And this is why I like the table in the previous questions. So what we can see now is that this is going up by 3 each time. So we've got a common difference, so it's linear or arithmetic. So what I can certainly say now is the following. We can say the number of posts. We're asked to write down an expression for the number of posts. I'm going to write this as an equation, but we can have the expression. We're not asked for the equation, and I'll show the difference in a moment. So we know that this is going to be 3n. If I do 3 times by 1, that's 3. What have I got to do to get to 6? The answer is add 3. Does that work here? Well, 3 times by 2 is going to give me 6, plus 3 gives me 9. This is the expression. 3n plus 3 is the expression, and I've turned it into an equation. So the number of posts is equal to 3n plus 3. All they're asking for is this part right here. That's the expression. It becomes an equation when I put the equal sign in. So if we go back to answering this question, as I said, all we would do at this stage is add now 12 lots of 3 because we want 20 in a row. But for this, we could write that n was equal to 20. So we'd simply substitute that in, and the posts would be now 3 lots of 20 plus 3. So that's going to give us 60 plus 3, which is 63. And you can see it's exactly the same as adding now for 12 lots of 3 on, which is going to give us 36. I personally think it's a lot easier, because if we were asked now for 104 enclosures, how many posts? The posts now would be equal to 3 lots of 104 plus the 3, and that's going to give us what, 312 plus the 3, which is 315. So it's a lot easier to work this way. If we were asked if there was now a number of enclosures that had, for example, now let's say 81 posts, let's think about this one here. What we could say now is that 81, that would be the number of posts, would be equal to 3n plus 3. I would subtract 3 from both sides, so 78 would be equal to 3n. And then I would divide both sides now by the 3, and that would give us that n was 26. So we could say now that if we wanted to find the number of enclosures with 81 posts, yes, it does exist, and it is now the 26, there are 26 enclosures in a row. So there we go, that's a nice functional question. So that's essentially it. All we're doing is looking at building up what we call an arithmetic or linear sequence. We simply check now for a common difference, whether that's increasing or decreasing, and we set up our little formula and then simply either find numbers in the sequence or check that numbers are in that sequence.